Okay, welcome to lesson 2.1. Okay, this unit is about probability. Now, this is personally one of my favorite units. I really enjoy dealing with probability. Unfortunately, it has to be one also that can be a little difficult sometimes. So today's lesson will probably be fairly easy, but after today you're going to be learning a whole bunch of rules. I would recommend that you keep track of those rules because you'll be given problems and you won't know which rule you're supposed to use. So if you have a list of the rules, you'll be able to deal with them. So with probability is finding out the chance that something can happen. All right. So what is the probability that that I don't show up for school? All right. What is the probability that I get in an accident on the ring road? This is what probability is. It's very realistic and lots of applications to the real world. There's lots of people get paid lots of money to study these things and to figure out actual probabilities. So what is probability and what are some of the rules associated with it? So here is my conceptual today. It's 2 slides. Conceptual is a little long. Most of it's common sense though. If you dealt with probability at all before, you should be fine. So here's the formula for probability. It's very, very long, but essentially what it says is that if you have a set of outcomes, so I'm going to use, just for purposes of the conceptual idea, a dice, right? So if you have a die, you have 6 sides on the die. That is the total number of outcomes. Right? If I have 6 sides on a die, I have 6 possibilities. And then it says for any event E. Now event E could mean I roll a 1, I roll a 2, I roll an even number, I roll a 7. Okay, believe it or not, there's a probability for that because I can't roll a 7. So anyway, so that's what's the event? What do I want to have happen? So in this case, if I were going to say what is if I wanted to roll a 1, what's the probability? Well, that can only happen once. So my probability that I roll a 1 is a 1 out of 6. That's the definition of probability. Okay, being able to do this. Now, it seems very simple in this case, but it is, and it is. I mean, it can be, but a lot of times we're dealing with more than just simple outcomes. So, probability is the idea of whatever your event is over the total number of possibilities that you have for that event, for the sample space. The sample space is how many possibilities do I have, or what possibilities do I have. Right? The next thing we're going to talk about is the complement. The complement is the opposite probability. So what is the probability that I don't roll a 1? Okay? And that's simply 1 minus the actual probability. And so this rule down here, this formula for the complement of events, okay, is just 1 minus the probability that an event happens. Okay? Now this shows 3 different possibilities for this. It's just to show you that there's more than one formula for this. So the probability of an event not happening is 1 minus the probability of the event. That's this right here. Okay? The probability of an event happening is 1 minus the probability that it doesn't happen. Okay? Now, probabilities, there's another rule we'll learn in just a few minutes, but they will always add up to 1. Okay? If I have 6 dice, there's 6 sides on the die, each possible side is 1/6. 1/6 plus 1/6 plus 1/6, 6 times is 1. Alright? So if I have the probability that an event happens and the probability that an event doesn't happen, if I add them together, I will always get 1. Okay? It's like percentages. Alright? So that's the first couple of rules with probability. Let's go to the next set. Okay, there are 4 rules here. I thought there were 6, but maybe there's only 4. That may be a different lesson. Okay, so I'm going to move this up here so we can see. Alright, so again, most of these are common sense, so I'm going to talk through them really fast, but they're common sense. So the probability of an event happening is between and including 0 and 1. Okay, that means that you can't have a probability bigger than 1. Realistically, there is not 115% probability that I'll do anything. Okay? It has to be between 0 and 1. It will be a fraction or a decimal. Probability rule number 2. Okay, if an event cannot occur, for example, if I'm rolling a single die and I say, what's the probability that I roll a 7? The probability is 0. Alright, that's probability rule number 2. I hope that one is common sense. If an event is certain, the probability is 1. So for example, if I roll a die and I say, what is the probability that I will get either a 1, a 2, a 3, a 4, a 5, or a 6? Well, the probability is 1, because I will get at least one of those numbers. Alright, and the probability rule number 4, we talked about this. If we were to add up all the probabilities of an event happening, of any events in and out sample space, we will get 1. So, I think we're ready to move on to examples. Okay, so most of this is going to be common sense and just using your brain a little bit as far as being able to find out probabilities. We're going to learn all kinds of rules in the next lesson, but this one is about just the general probability. So if a die is rolled 1 time, find these probabilities. I'm getting a number greater than 4. Now I want you to note that it does not say 4 and greater. So getting a number greater than 4, meaning I want to roll a 5 or a 6. Now my sample space is 1, 2, 3, 4, 5, 6. Those are all my possibilities. I have 6 possibilities. I want to roll a 5 or a 6. There's 2 of them there. That means my probability is 2 out of 6. I would ask that you also simplify these. So my probability is 1/3. Here's your practice problem. Okay. This is a little bit harder than the actual problem we just did. Again, I want to see if you know probabilities, if you can do this without, for some people this is going to be intuitive and you're going to figure it out really fast. For some of you it's going to take a little longer. We talked about cards I hope during our activity. So getting a 6 of clubs when it asked for that. Oh, I thought it asked something else. I'm sorry. 6 of clubs. When it asks for that, I hope you know how many of those are in the deck. If you don't, please refer to your paper that has the cards on it, or look it up online if you don't have that with you. Here's your solution. All right, so example number 2. What happens if I have 2 probabilities going on? It says if 2 die are rolled at one time, I have to move this because I can't see it. Okay. If 2 dice are rolled one time, find the probability of getting these results. Now, this is an interesting problem because this is saying I want a sum of 6. So I actually need to know how many possibilities do I have. All right, so I need to find all the sums of 6. So if I can roll 2 dice. I have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Now, different die, 2, 1. This is different than 1, 2 because this is the first die being 2. Okay, so that counts 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2. Okay, I'm going to shut up for a minute while I finish writing these down. So I have these probabilities. So how many do I have total? What is my sample space? Okay, well I have 6 and 6. I actually have 36 possibilities. Okay, that's going to be my number on the bottom. A sum of 6. So how many sums of 6 do I have? I have 1, 2, 3, 4, 5. I have 5 sums of 6. So the probability that I roll a 6 is 5 out of 36. A sum of 6. Okay. All right. Here's your practice problem. Go ahead, pause the video, give it a whirl. Check your answer. All right. Frequency distribution. So finding probabilities of frequency distribution. Basically, if we have a frequency distribution, we, to find a probability, we take the frequency for whatever class it is that we're checking and divide it by the total number that we have, all right? The cumulative. So, sorry, my phone's ringing in the middle of the video. All right, moving on. Okay, so here's an example. And now this doesn't have a frequency chart on there, but it actually has, this is frequency. So this is in a college class of 250 graduating seniors, 50 have jobs waiting, 10 are going to medical school, 20 are going to law school, and 80 are going to various kinds of other schools. So this is a frequency, all right? It's not in a frequency table, but it's a frequency. 50 is in the jobs category, 10 is in medical school, 20 is in law school, and 80 is other kinds of graduate school. Now, I want you to also notice that this is something sometimes you have to know something about what's going on in the problem. So you know medical school and law school are both considered graduate schools. So when I ask a question about graduate school, you have to include those in there. So A says, what is the probability that a student's going to graduate school? Well, I have 250, okay? And 50 have jobs waiting, 10 are going to medical school, 20 are going to law school, and 80 are going to various other kinds of graduate schools. So 80 plus 20 is 100, plus 10 is 110, plus 50 is 160. Okay, we can reduce that to 16 over 25. So that's A. Okay, what is the probability that a student is going to medical school? Simple, 10 out of 250, okay, 1/25. What is the probability that a student will have to start paying back her deferred student loans after 6 months. Aisha does not continue in school. Well, first of all, we need to see, does this add up? 50, 10, 20, and 80. Does that add up to 250? Or how many do I have that aren't doing anything? 80, 20, 10, and 50. So it's 110, 160. Oh, you know what? I messed up somewhere. But this is 160 total. So there's actually 90 students that don't have anything. So I have 90 who don't have anything, plus those that are starting to get jobs. So 90 plus 50 is 140. So it's 140, add up 250, 14 over 25 for C. Now I screwed up an A. I screwed up an A because I added those 50 that already had jobs. Okay, they're not going to graduate school. So I have 10 plus 20 plus 80 is 110. So then that's 11 out of 25. I'm sorry. So, alrighty, let's do a practice problem. Okay. Pretty simple one. Pause, do the problem, check the solution. Okay, they set it up in a frequency table to do the solution. You don't necessarily have to do that. And that's it. I will see you tomorrow.